Most artificial intelligence you see today isn't actually intelligent. It's impressive, it's useful, but it's not what the headlines promise. Across social media and investor presentations, AI is presented as if it's approaching human-level thinking. But the reality is far more technical and far more interesting. In the next few minutes, we're going to unpack what fake AI actually means. Not fake in the sense that it doesn't exist, but fake in the sense that the claims often don't match the architecture. We'll explore the difference between marketing and technical reality and why demos often look magical but fail in production. We'll look at the fundamental design that makes hallucinations inevitable, and most importantly, where AI actually works incredibly well. When I say most AI is fake, I mean three specific things. First, the claims often imply general intelligence. But the systems themselves are narrow statistical learners. They don't understand the world. They recognize patterns in datasets. Second, most demos are carefully curated edge cases. Inputs are controlled. Failures are reset. Only the best examples are shown. But messy real-world environments expose the limitations quickly. The magic fades when the guardrails are removed. Third, the incentives in the AI ecosystem reward hype over verification. Startups raise funding on ambitious visions. Companies sell transformation. Media simplifies the story, and the viral demo becomes more valuable than the honest result. To summarize, fake AI equals misleading claims, demo theater, and misaligned incentives. It's a structural problem. In a demo environment, everything is controlled, the prompts are carefully chosen, the data is clean, failures are quietly restarted, and the final clip shows only the best run. It's a performance, not a product. But production systems are very different. Real users generate unpredictable inputs. Data distributions drift over time. Latency budgets constrain complexity. Safety checks and compliance rules slow everything down. The magic begins to struggle. Look at the difference. On the left, demo world. Perfect prompts, controlled environments, and infinite retries. On the right, production world, data drift, monitoring, evaluation metrics, and very real operational costs. Ask engineers who have actually deployed these systems. The hardest part isn't the model itself. It's everything around the model. Retrieval pipelines, evaluation systems, human review layers, monitoring and correction. The viral moment is only the beginning. The real work happens in the unglamorous layers of maintenance and oversight. So, if the limitations are widely known among engineers, why does the hype continue? Because the incentives reward it. Investors fund bold visions, startups promise transformation, marketing teams simplify the narrative for the masses, and media outlets amplify the most exciting version of the story. Everyone benefits early, but the real costs appear later. Maintenance debt, prompt babysitting, governance challenges, and systems that require constant human supervision. It's a value chain built on excitement. First the vision, then the funding, then the inevitable press coverage, followed by pilot programs that often hit a wall. That's where the reality check happens. And it's often expensive. The real solution isn't to stop building AI. It's to measure what actually matters. Task-grounded evaluations, failure cost analysis, and honest baselines against existing systems. We need to stop comparing AI to magic. Here is the core technical truth. Most modern AI systems are stochastic pattern completion machines. Language models predict the next token in a sequence. Vision models map pixels to labels. They are statistical engines, but they don't have grounded models of the world. They don't know what an apple is. They know the word follows red. This is why hallucinations occur. When the model encounters uncertainty, it doesn't say, "I don't know." Instead, it generates the most statistically plausible continuation, which often sounds convincing but may be incorrect. There is also a deeper issue. As synthetic data enters training pipelines, models train on their own generated outputs. This feedback loop gradually reduces diversity in the data, and errors become amplified over time. This phenomenon is known as model collapse. It's the ultimate risk of an AI-only content ecosystem. None of this means AI is useless. In fact, when scoped correctly, AI is extremely powerful. It excels in specific areas. It excels in high-volume tasks with strong statistical patterns, ranking, search, summarization, code suggestions, anomaly detection, document classification. The real breakthroughs happen when models are part of robust systems. AI is best understood not as a thinking machine, but as a powerful statistical engine inside a larger framework. The next time you see a perfect AI demo, ask 5 simple questions. What inputs does it expect? How does it handle drift? How is truth verified? Through retrieval, tools, or review? And what is the actual cost when it fails? Who is responsible when it goes wrong? And perhaps most importantly, who benefits from this narrative? Most AI today isn't intelligent. It's a statistical mirror of human data, but that doesn't make it useless. When built with clear constraints, it's one of the most powerful tools ever created. The real mistake is believing the myth. Drop the boldest claim you've seen in the comments. Subscribe for more deep dives. I'm Stochastic Intelligence.